Welcome to the IoT Review, presenting unbiased insights on the industrial Internet of Things from experts around the world. And here's your host, Sravani Bhattacharjee, to discuss yet another fascinating aspect of the industrial IoT journey that may positively impact your business and your customers.
Hi and welcome to the IoT Review. If you ever wondered about blockchain and how it may impact the industrial Internet of Things, then you can sure expect a lot of interesting and rather disruptive insights in today's episode, because our guest today is someone who had been a long-time cryptocurrency expert, a prolific innovator, and he's currently working very passionately to make the potential of blockchain for the industrial internet a reality. So friends, let's welcome Andre De Castro, the founder and CEO of Blockchain of Things. Andre, welcome and thanks for joining us.
Thank you, Sravani, for having me here.
All right. So as an expert in blockchain, I know you offer a lot of thought leadership on the topic. So before we deep dive into the topic, why don't you give us a quick intro on distributed ledger technology and also the Bitcoin blockchain?
Okay, fantastic. The history of blockchain technology comes from the cryptocurrency called Bitcoin. It's actually the authoritative ledger that records all of the transactions that are sent between individuals when individuals send money in the form of this digital token between each other. This ledger is decentralized, meaning that there is no central authority. Like if we were to send money with PayPal, there would be a central authority, PayPal, that could block the transactions, right? In this system, there is no controlling central authority, and individuals can transact with each other peer-to-peer anywhere in the globe. So I could quickly send a transaction message to you if you're in India or if you're in South America, and it's a near instant transaction to send the money. The ledger itself is cryptographically secured. Presently, as of today, it's securing about $12 billion with a B of assets on this ledger for Bitcoin. It's been around for about 8.5 years. However, Bitcoin the currency is the first application to leverage this ledger. This ledger is very useful for many reasons. It has very powerful properties such as immutability. If you enter something into the ledger, it's a ledger of control, and it cannot be edited or deleted. So it allows for proof of occurrence. Whatever happens and gets logged to the ledger, you can use cryptographic proofs, they're mathematical proofs, to show that it actually occurred. And it's also a consensus-based system, meaning that every individual through that's part of the network, what we call full nodes, verify the occurrence of what occurred and come to consensus of the information before the information gets placed into the ledger. So think of it as an extremely democratic Excel spreadsheet, very, very powerful, where information gets logged, and we can use it for transactions, immutability, and all sorts of interesting properties we'll speak of.
All right. Thank you. Thank you very much for that intro, Andre. Now, blockchain is also gaining the center stage, as you mentioned, because of its immutability of the ledgers and also resiliency in terms of infrastructure resiliency, automating transactions, and so forth. Now, in your opinion, what are the top reasons to consider blockchain for industrial IoT?
Well, what a great question, because it's something that myself and my company have been thinking about for many, many years. One thing that's apparent is that today, transactions on the global Bitcoin blockchain, and it is global, it sits everywhere. Last study I read, it estimated that the computational power of Bitcoin was about 550 times Google's global infrastructure of processing. So that's quite large, and it grows every single day. we see transactions go from one individual to another individual, and they're never subverted. And every transaction on this global blockchain is transparent, meaning that we can see these transactions happening. And because we can see these transactions occurring, right, you would think that hackers would subvert these transactions. In 8.5 years of the existence of this ledger, never has a transaction been subverted. And we see transactions in the order of magnitude of 5, 10, 20 million, even $160 million. So that's quite a large incentive for a hacker to be able to subvert that transaction message. Yet none has ever been subverted because of the cryptographic nature of these messages. So I think industry is going to start to understand why this ledger can be applied to the Internet of Things and the industrial Internet of Things, especially considering some of the factors of what is starting to happen or what analysts predict will accelerate, which is hacking of billions of devices that are coming online in the Internet of Things as we speak. So that's one of the properties. The other property that is interesting in the ledger itself is what you touched on, which is immutability. Immutability allows us to register information when a product is manufactured and then prove its authenticity. So now we can imagine such industries such as pharmaceuticals that have a tremendous amount of fraud, registering information on the blockchain. So now individuals can prove that the pharmaceuticals they're receiving haven't been tampered with or are legitimate. They know where they've been manufactured and they know where it comes from. Or you could do such things to reduce fraud with transparency, such as in the advertising industry, there's $7.5 billion worth of fraud they're predicting for 2017. And a lot of the fraud happens within players in the middle of the advertising chain because they're not being transparent. So there are many, many applicabilities, not only from a security perspective, but from a logging and transparency and regulatory compliance perspective that large enterprises can take advantage of.
Mm-hmm. That sounds pretty disruptive, but yeah, I hear you that security is such a concern for the industrial IoT, and so blockchain has a promise there, given its cryptographic resilience, and also I also see that blockchain is more like a peer-to-peer communication, so the question of single point of failure also is something that it addresses. Do you think in those lines as well?
Oh, absolutely. The big elephant in the room today when it comes to the industrial internet and the Internet of Things is this concept that everybody has been jumping on, cloud infrastructure. Now, I do agree that cloud infrastructure is very, very powerful, but we can't take for granted that the cloud only means somebody else's computer, right? And usually cloud services tend to be centralized. And we see now, and we've seen recently, I think it was about a month ago, a major denial of service attack on Dyn DNS. And that denial of service attack took down half of the internet in North America. Now, Dyn DNS is a substantial company, and it probably has more infrastructure than most companies deploying industrial Internet of Things throughout the world. So now you can imagine that if a hacker can seize control of devices and send floods of information or denial of service attacks to Dyn DNS and bring half of the internet down in North America, imagine these companies who are replacing light bulbs all over a city, or for traffic lights and lampposts, or medical companies who are distributing devices that sometimes are implanted in humans, right, to monitor their health, and a lot of times to ensure that they're well. They could be attacked centrally. And the solution to this elephant in the room, is peer-to-peer communication. However, there aren't a lot of peer-to-peer solutions for IoT that exist today. And the ones that are out there have yet to be proven. Here we have an infrastructure called the global Bitcoin blockchain that has been proven as a peer-to-peer network. Ironically, when the Dyn DNS attack occurred, Bitcoin was unfazed. So people were happily sending cryptocurrency to each other all over the world. So if we can leverage the peer-to-peer nature of this structure, we can significantly change the game, not only from a security perspective, but from attack vector perspective. So hackers can no longer attack central nodes. They would have to attack dozens of nodes or peers, and that becomes impossible. Why? The nature of a denial of service attack is flooding central servers. The minute you have 3 locations and 4 locations, you divide up that flood into 1/4, and then it doesn't become a denial of service attack anymore. So it's incredibly important that enterprises take notice of peer-to-peer technology. I believe going into the future, and we already see recommendations coming from at the government level. I believe yesterday there was another report commissioned by the U.S. government on IoT security, and there'll be more and more pressure. So if corporations are listening to this and they're spending millions of dollars deploying cloud infrastructure solutions for IoT, and they're not considering peer-to-peer technology, I recommend that they reach us for us to help them, because it doesn't have to necessarily supplant what they're doing, but we can work with them and their existing infrastructure to add key peer-to-peer communication on where it's necessary to reduce the attack vector risks on what they're deploying.
Mm-hmm. Yeah, sure.
You spoke about the DDoS attack in Dyn DNS service, which I think really showcases how the internet has evolved over the years, its hierarchical nature, with many fundamental services centralized with certain providers. And also, as an industry, it took us almost a decade to accept and get convinced about the cloud, which again is not decentralized. So what you are sharing today with us, isn't it quite disruptive? Something to ponder upon, and I'm sure it calls for a shift in mindset also. Now, in context of IoT, some of us may be wondering, if we take up a typical industrial IoT use case, let's say a manufacturing plant with several IoT devices spread out geographically. Now, these devices exchange massive volumes of sensor data. To process and analyze this high volume of data, we have centralized servers both at the edge and in the cloud. Now, in context of such industrial IoT architectures that we commonly talk about, where does blockchain fit in, and how can we really leverage its potential?
It is true that certain blockchains, and certainly the only tried, tested, true, and trusted global Bitcoin blockchain has some limitations in message and storage size. Let me give you an example. Today, the messaging field on the global Bitcoin blockchain is only 80 bytes. Now, one would think that that's very, very small. However, there are very large companies that today have significant IoT footprints. Sigfox comes to mind, and Sigfox is a very, very well-respected company, and their communication is limited to 12K, significantly less than the Bitcoin blockchain. Well, the reason for that is simple. We can fit hundreds of millions of commands inside of 12K of information. So if we think of general devices, we think of a device that's usually built purposefully. Let me make an outrageous example. You might have a very fancy coffee maker. Let's say it's for Starbucks. What does it do? You can turn it on, you can turn it off, you can grind beans, you can kick off maybe a self-cleaning mode, you can create a cappuccino, you can create a an espresso, a double espresso. So there's only really maybe, 30, 40 functions that device can do. We can fit those commands and interpret them in one byte of information, sometimes less than that. So from a command and control perspective, there aren't really any limitations. Now, when we have devices that gather information, I think a lot of times we take for granted, and I like to make an analogy with medical devices. You might have a medical device that's monitoring your heart. Let's say some type of implanted defibrillator. Now, does the information from that device always get uploaded? Not necessarily. Most of the times, we only want the information when an anomaly occurs, right? And hopefully, an anomaly only occurs when you're having a heart attack, and you're not having a heart attack 10 times a day, right? So there's also that aspect. When it comes to devices that collect a lot of data, let's use an example such as an environmental device. Maybe I have a device on a pole that's measuring air quality every 5 seconds, and the air quality data it's measuring is a good amount of data. It's not only temperature, it's humidity, it's different particles in the air, and so forth. We can use secure channels of communication for command and control of the device itself, and less secure channels of communication through the internet to store the information. So we can literally grab all of that information, send a command and control to that device that's monitoring air quality, and have the device encrypt that data, and that encrypted data can be put and stored in a file system through a secondary channel, right? So I don't think that the security and peer-to-peer nature is as important when collecting data, because the data you're collecting needs to be centralized. But it's incredibly important when it comes to security and thwarting attacks from hackers and such. So I think we need to consider the different aspects of the industrial internet and how data can be collected, and how command and control signals are significantly different than data itself. So we can't do away with understanding the nuances, because the devils are always in the details. And I don't think that large amounts of data is an impediment or a hindrance to implementing global peer-to-peer secure communication on the global blockchain.
Yeah, and I also hear you say that although the main value proposition of the Industrial IoT is around centralized servers and applications which run the analytics either at the edge or on cloud. Now, the real value, as we say, of the IoT really lies in analytics and the intelligence we derive from those data analytics. But you're kind of segregating the two pieces. So can you just clarify that particular aspect before we move forward?
Yes, I am segregating the two pieces, right? Because they're ultimately corporations want their information in a central repository. And I don't think there's anything wrong with that, right? I think that there's an extreme amount of value to be said. Now, the blockchain can control the immutability of that data. For instance, we can have large amounts of information. We can hash that information, and hashing is basically creating a fingerprint across the data that if anything were to change on that data, if a comma were to be added or a space in that document or in that data, the fingerprint would change. We can store that fingerprint onto the blockchain, and later we can compare to see if the data that we've gotten, anyone has touched or messed with in any way, right? So we could use the blockchain for that type of benefit, where large amounts of data can have fingerprints, and we can compare those fingerprints and use the fact that we can trust the immutable global blockchain to compare that data hasn't been tampered with by anyone. Now, we don't need to necessarily say, oh, because this peer-to-peer global infrastructure isn't necessarily going to directly hold a tremendous amount of data when it comes to analytics. It isn't a substantially useful ledger, even when it comes to ensuring the quality of the data. right? So there are many aspects to this.
Okay. And how about computing resources? Can you speak a little bit? Because many IoT devices, such as connected sensors, as we know, are very low in memory and processing resource-wise. So would that put a constraint on being a node in the blockchain?
Yes, I think in a lot of ways, if you went to try to develop a solution yourself, you would probably come into some challenges when it comes to devices on the dumber spectrum, devices that aren't as powerful in processing power or don't have as much storage. And that's where blockchain of things excels. Our product, which is called Catenis Enterprise, offers a web services layer for rapid integration into the global Bitcoin blockchain. It simplifies and accelerates secure global peer-to-peer device messaging, exchanging of digital assets, and recording of immutable data for regulatory compliance. And because they're simple web service APIs, we can have the dumbest of devices make a web services call. Literally, you can have devices in the $5 to $10 range that are capable of making web services calls. We've built the product with IoT in mind. We've built the product with enterprises in mind, understanding that today a lot of the impediments to be able to deploy solutions for the enterprise is a lack of knowledge of some of these cryptographic primitives and disjointed libraries that exist to be able to leverage the global Bitcoin blockchain. And we want to make it very simple where someone with no knowledge whatsoever of all of the messy cryptographic stuff that underlies this very, very powerful ledger can quickly take advantage of it without needing to know the basics of the details, right? Because it's very dense and terse details, specifically in the field of cryptography, right, that a lot of engineers don't necessarily have. So we think it's an advantage to be able to bring Catenis to market, to be able to allow companies to leverage this technology quickly and also use it on extremely inexpensive devices to take advantage of not only the security, the peer-to-peer nature of this communication infrastructure. And remember, this communication infrastructure is highly redundant and as fault tolerant as you can get because every single part of the ledger is globally replicated to every part of the planet. So now you can start building supply chain scenarios and things of that nature when you can quickly generate endpoints that you can put on your iPhone app, on your supercomputer at your firm, on a device on a container on a ship, on an assembly line, recording goods coming off of the assembly line. So we're trying to enable general purpose APIs that companies can take quickly, leverage, place on any type of device, be it an assembly line to a robotic arm that speaks to some other system across the planet very, very quickly.
Yeah, it's almost like when we talk about this point-to-point networks, it almost reminds me of the mesh networks that we have. And there may be certain other challenges. We already talked about the memory and processing power and so forth, but there may be other challenges in terms of scalability and so forth. So those we have to work through. And thanks for telling us also about the product that you are working on to make adoption of blockchain more feasible. Another area that I wanted to touch upon is Bitcoin blockchain. The perceptions, the current perceptions we have, and in terms of adoption, when it comes to Bitcoin blockchain, in terms of tracing identity, validations, or lack of it. So those are some of the perceptions that cloud the whole concept of Bitcoin blockchain. So when we talk about adoption at an industrial enterprise level, what do you say about those perceptions about Bitcoin blockchain?
I believe you're referring to the fact that initially Bitcoin has gotten a black eye because it was involved with maybe some negative connotations. Initially, the news came out and talked about things such as Silk Road, which was a drug marketplace, and those things. Is that what you're referring to? The fear and hesitations that come from its history?
Right. And also the tracing identity. Yeah, you do not need to reveal your identity to be in a Bitcoin blockchain, right? So I'm coming from that. Yeah, and you are right. The black eye it got from all the different usages.
Yes. Well, I think once again we have to separate the cryptocurrency called blockchain, or these currency tokens, and how individuals had chosen to use it early on, to the power of the distributed ledger, right? Just because someone has chosen to use a currency in some negative way doesn't necessarily mean that the underlying ledger that secures this currency, that no one has been able to steal the currency itself from the ledger, is a very, very powerful proposition. Now, we've heard in the news, and the news always likes to say, oh, Bitcoin's been hacked. Well, that's not true. Bitcoin has never been hacked. What's been hacked has been exchanges or intermediary companies that get public-private keys and stored them in databases, right? In SQL databases and Oracle databases and MongoDB databases. And they don't know how to secure those databases. So the hackers come in, they penetrate those databases to steal the private keys, because if you have the private key, you can unlock and spend the Bitcoins that are underneath. So Bitcoin's really never been hacked. What's actually been hacked are third-party intermediaries who don't know how to secure those keys itself. So we hear a lot of hype in the media, but we need to abstract that hype of hacking, which really doesn't relate to the blockchain itself. I mean, right now as we're speaking, I have the whole blockchain on my laptop. It means that I have 12 billion, let me repeat that, $12 billion worth of Bitcoin assets on my laptop, right? And every hacker in the world and every state government has the same thing, because the blockchain is globally replicated. Yet no one but the owner of the keys have access to their money, their own money. So it's highly secured. Every line of code is open source, and everybody has access to read every line of code, and no one's been able to penetrate it. So it has come with some black eyes in the past, but we should not fear that, because what we're talking about is using the global ledger itself. And what my company does is we abstract all of the Bitcoin and cryptocurrency. So you as a company, you would come to us through a PO or a credit card, and you would buy what we call Catenis messages. Catenis messages are not cryptocurrency. They're not tokens. It's a control mechanism that our company uses to be able to allow the developers to send messages, to record immutable information on the blockchain, or to send messages between one and n number of devices throughout the world. So I could send a message from New York to Tokyo to a device in Tokyo, and so forth and so on. So let's not think, we need to separate the ledger itself from the previous black eyes it's had, because a ledger is just a very, very secure technology. Think of it as a SQL or Oracle database with very, very special features that is basically a free infrastructure that lives throughout the world. You only pay a minimum fee for the transaction itself, and it's recorded. From this concept that, you know, some naughty individuals have used the currency for not great things in the past. The fact that it's pseudo-anonymous, and what we mean by pseudo-anonymous means that every endnode or every wallet has an ID, and that ID is sort of like a Swiss bank account, right? So if you know the individual who owns that ID, then it's not anonymous. That's why we call it pseudo-anonymous. But when it comes to the industrial internet, those IDs refer to products and devices, right? And I don't think that most companies publish their product and device IDs when they do communication to their devices on the public realm anyway. So I don't think it really affects the Internet of Things. And we make it very, very easy to deal with all of the messy stuff when it comes to the global Bitcoin blockchain, making it rapid development for corporations, saving them a lot of money and decreasing time to market for them. So those concerns sort of go away. We don't even have the concept of developer and IT department holding cryptocurrency or holding the type of keys that they can get direct access to the underlying value, which allows companies to feel secure in deploying applications and leveraging the global ledger.
Okay, yeah, that's excellent. Some excellent points to debunk some of the myths. I intentionally kind of brought this up because there could be some resistances as we learn more about blockchain applicability. So great content, great discussion, Andre. And thank you so much for coming and sharing all those insights. Now, do you want to say anything in the closing? We are almost close to our chat. So anything you want to share?
Yes, absolutely. My company is not only releasing product early to mid 2017 that will be generally available, but we're already working with large corporations today to solve these problems, right? Although we haven't released our product to the public, we do have APIs and testing platforms and those things. And we do provide consulting services for corporations, so they can feel free to go to our website or our Facebook account or LinkedIn account, reach out to us in the information that you see available. You can go to blockchainofthings.com, scroll down to the bottom. You'll see a phone number to reach us, and we can help you if you're considering using blockchain and peer-to-peer technology for your implementation.
Wonderful. Thank you so much, Andre, for joining us today and helping us learn about blockchain and the distributed peer-to-peer technology, and also how blockchain can be applied in various enterprise IoT use cases. And of course, security, which is such a big concern in IoT deployments today. So it was really great to discuss with you how blockchain has a promise when it comes to securing IoT deployments. So again, thank you. And we hope you'll come back and share with us more insights in the future.
Thank you for having me.
You've listened to the IoT Review, an exclusive platform to discuss, learn, and harness the power of the industrial Internet of Things. To receive more insightful episodes, subscribe by visiting iot.irecamedia.com. We thank you for your support in empowering industries around the globe with the power of IoT.